Hello friends, I am Satyendra and today in this lecture video I am going to explain you the projectile motion. Okay, so the projectile motion is important at all the levels. Okay, for MSc, for CSIR net, for gate, for jest, at all levels the projectile motion is quite significant. So we will today discuss a bit about the projectile motion. Okay, so the first thing is that projectile motion is a two-dimensional motion. By two-dimensional motion we mean that a projectile motion is confined to a plane. Okay, so it is an example of a motion in plane. Okay, then let's come to the definition of the projectile motion. If an object is thrown with some initial velocity u, okay, in the direction other than vertical, the object move in a curved path in a vertical plane under acceleration due to gravity directed vertically downwards and return back on the ground at some other place. This motion is called the projectile motion. Okay, so uh, the particle, the object which is thrown, is called the projectile, and the curve traced by the projectile is called the trajectory. Okay, so we have just now we have read the definition. Okay, but let me describe you this definition with the help of an example. Okay, with the help of diagrams, that I mean that. Okay, so now as I told you that what is projectile motion in the definition, let's take this diagram. So if an object, this is the object. Okay, so if an object is thrown with initial velocity u, okay, at some at some angle, so you can see that it is thrown with the initial velocity u. Okay, but the angle is not vertical, it is not thrown in vertically. Okay, it is thrown at some angle. Okay, that angle is theta or alpha. Okay, that angle is alpha, let. Okay, then what happens, this projectile, okay, this projectile then moves in the vertical plane, and after some time it moves under the effect of gravity. Okay, so all the time the gravity acts on it, and after some time, that is after the time of flight, it falls on the ground at some other position. So it started from some position and it fall down at some other position, and it moved in the vertical plane. Okay, under the effect of the acceleration due to gravity. So this type of motion is called the projectile motion. Okay, and the path that you look at, this path is the parabolic path. Okay, okay, now as now we already know what is projectile motion, let's describe you the different types of projectile motion that we come across in our daily life. Okay, so the first type of projectile motion is this one. Here you stand on the ground in the plane surface, you throw an object, and it again, after traveling, it again falls on the ground at some other position. Okay, okay, the other type of projectile motion is that you might throw an object from the top of any building. Okay, so in that case it will travel like this and will fall at some other point. Okay, okay, the third kind of projectile motion is this one. You might be standing on an inclined plane which is inclined an angle theta. Okay, okay, with the ground, okay, and when you throw the projectile from here, it will fall at this point. So this kind of motion is also the projectile motion. Okay, let's come to the fourth point. In the fourth point, you might throw the projectile from this point in an inclined plane, and the projectile will fall at this point. So this type of motion is again called the projectile motion. Okay, so these are the four basic types of projectile motion. Okay, there are of course more types of projectile motion that we will discuss in some other lecture, but as a beginner we would like to describe you the most familiar projectile motions with their mathematical derivations. Okay, now friends, there are some important terms or terminologies in projectile motion, okay, that I am going to explain you one by one. Okay, so first thing is that in order to understand the terminology, you have to see the diagram carefully. Okay, so look at this diagram carefully. The projectile is thrown from here and it travels through the path OAB. Okay, here is OAB. Okay, at the point B it falls down. Okay, and the time it took to travel, okay, it took some time to travel. Okay, and during the motion the gravity was always downwards. Okay, that means the gravity was negative, its direction was towards negative by direction. Okay, okay, now let's come to the some terminologies. Okay, one more thing that you have to know is that u is the initial velocity, okay, here with which the object was thrown. Okay, now let's come to the terminologies. Okay, so the point o is from where the object is thrown, is called the point of projection. Now the angle alpha at which the projectile is thrown is called the angle of projection. The It is also the angle which the velocity vector makes with the x-axis. Okay, that is called the angle of projection. Now horizontal range. Okay, so what is horizontal range? So suppose you throw the particle from here, the object from here, and the horizontal distance traveled by the projectile in the x direction is called the range. So you can see that this is the horizontal range. It is the distance traveled in the horizontal direction or in the x direction. So this is the horizontal range. So r equals to ob. Okay, this is the horizontal range. Now what is then the h, that is the maximum height. So when the projectile is thrown, okay, from the point o, it is thrown, its velocity slowly increases, sorry, slowly decreases. Okay, at a point a its velocity completely becomes zeros, and then it moves in the opposite direction towards the ground. So the maximum height that is attained by the projectile during its motion is called the maximum height and is denoted by h. So h is the maximum height up to which the projectile has gone above the ground. Okay, it is the vertical height. Now the time of flight. Okay, so the time of flight is the time taken by the particle or the projectile in traveling the path OAB. So let's come to the diagram. So the time taken by the projectile to travel from O to A to B. So that total time is called the time of flight. Okay, so now you have finished the basic terminologies. Okay, now let's go to the mathematical part. Okay. So before studying the projectile motion, you need the following concepts. So before going into the actual derivations of horizontal range, of time of flight, of maximum height, we have to know the equations of motion. Okay, these, without the equations of motion you cannot study the projectile motion. Okay, so the first equation of motion is v equals to u plus at. Here your v, u, okay, and this a is also the vector. Okay, so these all are the vector quantities. Okay, so I am writing this equation of motion in x component as well as in the y component. So in the x direction, the equation of motion will become like this. Okay, that means we will take only the x component. Okay, and in the y direction we will take only the y components. So equation of motion in the y direction will be like this. Okay, so here v is equals to vx I plus vy j. Okay, then u, similarly u vector is equals to ux I plus uy j. Okay, and then in the similar fashion a is like axi plus ay j. Okay, so if you substitute all these values in this equation, okay, then you will directly come to our these equations on comparing the x and the y component. So don't get confused. Okay, don't get confused. Simply see that, simply you can see that this is the x component. Okay, and this is the y component for the first equation of motion. Now the second equation of motion, we all know the second equation of motion. In this, it is written in the vector notation. Okay, and in the x direction, in the x dimension, the equation of motion will be like this, and then in the y direction the equation of motion will be like this. Okay, so now let's come to the third equation of motion. The third equation of motion is here. Okay, and and in the x and y component, if I want to write this equation, then that will become like this in the x direction, and it will become like this in the y direction. Okay, so this is how our three equations of motion in x and y directions are written. So you might be wondering why I'm taking x directions, y directions in separately. So the reason is that the motion of the projectile is in the two dimensions, that means x and y. So that's why I am considering here the two dimensions. Okay, don't worry, everything will become very clear to you as I will proceed. Okay, now the motion of projectile thrown from the ground making an angle with the horizontal. So in this, currently in this case, we will study this projectile motion. In this projectile motion, the projectile is thrown from the ground. You can see that here it is ground and here it is also ground. It is thrown from the ground and objects fall on the back on the ground after some time, and it makes an angle alpha thrown with the initial velocity u. Okay, so here h is the maximum height. Okay, r is the horizontal range. Okay, and here is our y direction, here is our x direction. And now at this point it is very important for you to understand that at all the time during the motion, at all the time during the projectile motion, the x component of the velocity, here you can see that the x component of the velocity, it should be equals to u cos alpha. So this in this so velocity along the x direction is constant at all the time during the motion. The reason is that along the x direction there is no acceleration, there is no force acting in the x direction. So in the x direction there is the velocity is constant all the time during the motion. Okay, now the velocity along the y direction should be u sine alpha. Okay, now in the y direction we know that the acceleration g due to gravity is always working, which is minus g. So that is the reason why this component of the velocity will have different magnitude at different heights. Okay, so this component will change, but this component is will be constant. Okay, it will be the constant of motion. Okay, now as the acceleration is towards the downwards direction in the negative y direction, so ay, the acceleration along y will be minus g, and there is no acceleration along the x direction, so ax is 0. And it is very important to know this concept. Okay, now let's calculate the time of flight. So as already told you, the time taken to project by the projectile to complete its motion is called the time of flight. Okay, so you can now see that now at the point at the point A. Okay, okay friends. Okay, so what you have to see at this point, see, the projectile is thrown from the point A. Okay, the projectile is thrown from the point A, from the point O, sorry, it is thrown from the point O. Okay, so at this point, at the point O, the velocity u is the initial velocity. Okay, so initial velocity in the x direction will be ux. Okay, it will be ux, and by trigonometry ux should be equals to u cos alpha. Okay, and the initial velocity in the y direction will be u sine alpha. It is the velocity along the y direction, initial velocity. Okay, so this is an important thing. Okay, now you can see that the projectile started from O. Okay, and if we see its displacement as y, okay, as y is the displacement along y, so it started from this point, it reached at this point, so then the displacement at this point will be this much. And when the projectile reached at this point, then the displacement along this direction will become 0. That means particle in the y direction went above the ground and went again came to the ground, so its y component of the displacement is 0. Okay, so that is why at point B, okay, so that's why at point B as y equals to 0. Okay, and acceleration at all the time during the motion will be minus g. Okay, so you don't look at this point, this is written by mistake. Okay, okay, now it is important to see that what we used a simple u for the magnitude of the u. Okay, now at each point it is important to note that ax should be 0 because there is no acceleration along x direction. Ay will be, that is acceleration along y will be minus g, and at point as already explained, okay, as already explained, okay, at point B the sx means the displacement along the x direction will be equals to range but the displacement along the y direction will be 0, because in y direction net displacement is 0. Okay, now using this equation, we will use this equation, second equation of motion, and the y component is used to find out the time of flight t. Okay, so at point B you can see that the net displacement along the y direction is 0. The initial velocity along the y direction is u sin alpha. T will be the time of flight, because particle went up and went down, so it took the time, that is the t is the time of flight. Okay, and then ay is minus g. Okay, then t is again the time of flight, so we have plugged the values, then simply we solved it further. Okay, I took out the t common, it equated equals to 0, then it gave me two values. Okay, so there are two time of flights, so this will be the your valid time of flight. This is that time of flight when the particle didn't started, so this is your right formula. Okay, so this is the total time taken by the particle to travel through its entire motion. Okay, so this is the time of flight, and it is very important for you to remember this formula. Okay, remember this formula, this is the time of flight. Okay, now we will study the horizontal range. So what is the horizontal range? You can see that horizontal range is r, and it is the displacement of the projectile in the x direction, that is at point B, Sx is equals to r. Okay, that is the range. Okay, so at point B, time will be equals to the time of flight, that is the time taken to complete its motion. Sx will be equals to its range. Okay, and ux, the initial velocity along the x direction, is u cos alpha, that is already explained to you. Now we will use this equation, second equation of motion, along the x direction, and now we have plugged the values. So this is r, this is the initial velocity along the x direction, it is value is put it, and t is the time of flight that we have used. Here ax is 0, that's why here whole quantity will become 0. Okay, now if you solve this, we have plugged the value of t from our earlier calculation, which was here this much. Okay, t equals to 2u sin alpha upon g. I have plugged the value, I then solved it, I got this, and then I further simplified it to this form, where I have used this formula to simplify it. Okay, so this is the range. Okay, so now you have calculated the range of the projectile. Okay, so how much distance it traveled on the ground. Okay, so you have calculated the range. Now let's go to the other part. Now what we will do now in this section, we will calculate the maximum height. Maximum height is the height, that is the maximum height that the projectile attains in its motion. So when the projectile is thrown, its velocity goes on decreasing. It when reaches to its maximum height, it becomes 0. That means uy will become 0 at this point. Okay, at this point the means that in the y direction the velocity will become 0 for an instant. Okay, but you always have to note down that the ux will always have this magnitude, it will never change, it is the constant of motion, but this component continuously changes. Okay, and at this point the uy will become the maximum, okay, before striking the ground. Okay, but here in order to find the maximum height, the most important concept that you have to note down is that the ax is equals to 0, ay equals to minus g, and at this point the velocity is 0, the y component of the velocity is 0. Okay, so at point a, okay, at point a, vy equals to 0. Okay, vy is equals to 0. As told you that for an instant the velocity becomes 0 in the y direction. Sy, okay, the displacement along the y direction will be, that means Sy will be equal to maximum height. Now we will use our third equation of motion, okay, and it is in the y direction. So let's plug the value. This is 0, as already explained you. Uy, this is the initial velocity along the y direction, okay, that is the value is plugged properly. The value of ay is written, sy is replaced by h. On solving it, you arrive at this equation, and this equation gives you the maximum height which is attained by the projectile. Okay, so you have completed your projectile motion. Okay friends, thanks for watching this video. Thank you very much. If you like my video, then please share with your friends. Okay, subscribe my channel and please like the videos. Okay, thank you very much.